Unless your organisation or team is seriously dysfunctional, we all want to do a good job. There's not much better in a work setting than feeling pride in our work. From an organisational point of view, we want people to take ownership and feel pride in their work, as well as to produce new things quickly and efficiently. That's how you get great products and great teams. Working on something cool helps, but the real route to being able to take pride in our work is to do the work with high quality. So what does quality in software really mean, and how do we achieve it? Hi, I'm Dave Farley of Continuous Delivery. Welcome to my channel. If you haven't been here before, please do hit subscribe, and if you enjoy the video today, hit like as well. I'd like to begin by thanking our sponsors, Harness, Equal Experts, Octopus and SpecFlow. They're all helping us to grow our channel, so please support them by checking out their links in the description below. Continuous delivery is the highest quality approach to creating software that we've found so far. If you'd like to learn more about continuous delivery and how to apply it, check out my training course, Better Software Faster. Again, link below. When we start work on a change, whatever its nature, with some kind of goal in mind. Fix a bug, add a new feature, make the code base better, whatever it might be. But whatever that goal is, there's another aspect that matters, the quality of the work that we do. The trouble is that this is quite a slippery idea. What do we really mean by quality? And it's kind of contextual. If you're writing software for an online bookshop or a game, sure, you may suffer some reputational damage or loss of income if the quality is poor, but that's going to be different to building a flight control system or a medical device that can kill people. So certainly there is no one-size-fits-all answer. At least to the degree that we care and are prepared to invest in quality. However, that doesn't mean the quality is irrelevant for bookshops and games. It never is. If I get a puncture in the tyre of my car, I could decide to fix it by putting a sticking plaster over the hole. This is a completely stupid idea, of course. Physics means that this won't work. The glue on the plaster won't be strong enough to resist the air pressure in the tyre. One of the problems and enormous advantages of software is that we are less constrained by physics. We could easily make the software equivalent of the sticking plaster fix, and it will work, but only sort of. A friend of mine once worked in one of the first online internet banking systems. They had a serious performance problem. The software worked fine in test, but was dreadful in real use. After some investigation, my friend found that someone had fixed a nasty concurrency bug. My guess is that those people were probably under some time pressure and wanted to get the job done quickly at the time. So they'd simply put a synchronization block around the problem piece of code. This was the sticking plaster on the tyre. In this case, the piece of code was central to the use of the banking system. So it meant that this multi-user distributed system with tens of thousands of users channeled all of the traffic through this piece of code one at a time, queuing up all the other requests. This internet bank could service one concurrent customer at a time. It's easy for us to make these kinds of mistakes, precisely because this is the nature of software and that it's so unconstrained. This is both its strength and its weakness. To control this problem, we need to be a bit more cautious in how we make changes. This is much more complicated than just answering the question, does it work? That's far too low a bar. The synchronization block in the banking system worked. The fix fixed the problem, but it created new problems along the way. So our code needs to work, sure, but it also needs not to add new problems. This is part of what we mean by quality work. Software development is complex and a marathon, not a sprint. So as well as working and not creating new problems, it also has to keep working and allow us to keep making changes. So the other vital aspect of quality is, can I continue to do useful work afterwards? There is a measurable economic impact of quality in software. Teams that produce high quality work are more efficient, more productive than teams that don't. Teams with high scores in stability and throughput spend 44% more time on new features, new work, than teams with low quality, who fritter away all of that effort on putting sticking plasters on the mistakes of the past, fixing bugs and answering support calls. I would argue that the following ideas are markers of technical quality, and so the habitability of the code, whatever the nature of that code. Good quality code is modular, cohesive, has good separation of concerns, exhibits information hiding, and is loosely coupled. Whatever your code is for, whatever technologies you use, if you imagine two versions of it, one that is modular and cohesive, with good separation of concerns, good lines of abstraction, information hiding, and loosely coupled, that version will be easier to change, nicer to work in, more flexible in the face of change, easier to test, more readable, and probably more efficient too, than the other badly coupled, poorly cohesive big ball of mud. The technical quality of our systems is an investment in being able to sustain a fast pace. I spoke about this in an earlier video. So there's much more to quality than simply answering the question, does it work? Here's a list of things that we are probably interested in. Bug prevention. How do we work to avoid putting bugs into new code? Bug detection. How do we notice when we break something that we already have or that a bug has made it past our prevention attempts? User satisfaction. Is our code nice to use? Does it help people do something that they care about? Software quality. Is our code habitable? Can we continue to make progress as time goes on and as the software grows in complexity? Quality and performance. Is it fast enough, scalable enough, secure enough, robust enough? And confidence in the product. Are we confident enough to let this change loose on our users? If something goes wrong, are we ready? Will we be able to tell that something went wrong, and can we fix it? The traditional approach to these types of quality is, I am sorry to say, fairly naive. That is, for a development team to abdicate much of the responsibility for pretty much all of it to somebody else. This is back to putting sticking plasters on car tyres. Let's think about the anti-patterns first, and then where I think the responsibility for each of these things should really lie. In great teams, quality is a whole team focus. Everyone sees achieving a high quality result as being an important part of their job. Lots of teams don't work like this though. Business people tend to overload teams with too much work, driving them to optimize for feature delivery. This is a terrible metric for success. It drives people to shortcut and so make bad decisions that end up with them going slower, not faster over time. Developers often try to please their bosses by reducing the quality of their work. As I said in a previous video, if you've ever given an estimate that didn't include either testing or refactoring, you did this. The developers assume that quality is the responsibility of someone else. Someone downstream, a QA team perhaps. The QA team see their responsibility as gatekeepers for quality, standing at the doors of production and saying, "You shall not pass," to crappy code. The problems here are numerous, and the result is nearly always a low quality outcome. Lots of bugs in production and code that's hard to change. In large part, this is a structural problem. The responsibilities are all in the wrong places. Let's take a look at the different kinds of quality that we care about and see how we could do better. Bug prevention. Developers write the code, so clearly this must be a developer responsibility. A product owner can't prevent bugs with requirements, and you can't prevent bugs after the fact by a QA person testing the finished buggy code. So devs need to work in a way that prevents or at least reduces the chances of them creating new bugs in the first place. Developers are often a bit overconfident in their own code. The trouble is that even simple code has lots of ways to go wrong, and we developers are very good at finding them. A 2014 analysis of software production failures found that 77% of production failures can be reproduced by a unit test. 35% of the catastrophic production failures are caused by trivial mistakes in error handling logic, ones that simply violate best programming practices and that can be detected without any system-specific knowledge. So if we unit tested as part of our normal everyday development, and we unit tested the failure cases as well as the success cases, we would trivially eliminate 35% of the bugs that we added to new code, and maybe as many as 77%. That's a very big saving in support calls, debugging and bug triage meetings. So this is obviously, clearly a developer responsibility. What about bug detection? This is about finding bugs once they've made it into the code. Traditional teams farm this off to a QA team, or maybe some form of user acceptance testing down the line. Well, we've just developed code with some automated tests to try and stop us putting the bugs in the first place. Waiting for days or weeks to find out from the QA team or the user acceptance testing that we added a bug is pretty horrible. So it would be much nicer if we could spot our mistakes sooner. So we may as well run the tests that we've just created all of the time. If we automate this, we can get the earliest possible feedback for almost zero extra cost this way. So this too is clearly a development team responsibility. Developers are the people that put bugs into code, so their job is to spot the bugs and fix them as quickly and as efficiently as possible. Any bug that someone else finds after that is going to be more difficult to reproduce, more difficult to understand, and more difficult to fix. So let's try and make it so that we spot more bugs than anyone else. We're not going to be able to think of everything. Some bugs will still get through. Our job as developers, though, is to minimize how many. The more bugs we allow through, the slower we will go overall. So it's in no one's interest to cut corners on this form of quality. Work in ways that minimize the amount of bugs that you put into the code in the first place. Then work in ways that find any that you missed as soon as possible after that. Next in the list, user satisfaction. This takes a variety of forms. Is the software nice to use? Certainly we want developers to care about this. If you are building something that you think is bad and you wouldn't like to use yourself, then you should be trying to figure out how to make it better. But in this case, I don't think it's only down to developers. This is a useful role for QA people or testers too. I think it's a bad idea to use testers as gatekeepers, and it's not their job to do regression testing. Human beings are too slow, too expensive, and are bad at being repeatable and reliable for this kind of repetitive work. Regression testing is for the machines, so we should automate all of that. But humans are great at the more subjective valuations of quality. Is the system nice to use? Does it make sense to me as a user? Is it clear how I should make progress as I'm navigating the system? These sorts of ideas are difficult to write automated tests for. I think of this as a form of exploratory evaluation of the quality of our systems, a kind of surfing the leading edge of changes as they are made. As developers change the system, testers use the new features and give the developers feedback on the subjective sense of using them. Their job's not to find bugs. The automation that the developers create and maintain should find the vast majority of bugs. Their job is to evaluate these more subjective qualities of the system. Software quality. Once again, we are firmly back in the hands of the developers. We are the professionals at creating software. We are the experts. It's down to us and no one else to decide what good quality job means in this context, and to allow ourselves the time to do it. We should not be asking for permission from managers, product owners, or anybody else to do good quality work. This is our responsibility, our duty of care. If managers or product owners are trying to limit focus on these qualities of our system, they're making a big mistake and are trying to optimize the wrong things. The most effective tool that I know of to allow us to build high quality software is test-driven development. So not only do we want to unit test our code to reduce the number of bugs that we add, we want to write those unit tests before we write the code. This encourages us to build code that has those hallmarks of technical quality that I began with: modularity, cohesion, separation of concerns, abstraction, and loose coupling. Test-driven development forces us to write code that's testable because we're writing the test first. Testable code has all of these properties. Quality and performance. There is certainly a role here for setting the bounds of quality metrics that we care about. How fast does it need to be? How resilient? How secure? All of these are questions that are really business decisions. And for most systems, they will probably evolve over time too. Developers and development teams certainly should be involved in the conversations to discuss these ideas. But our role as developers in these conversations is really to inform decision makers of the relative costs of the options. You want it to be completely secure? It's going to involve this amount of work. You want it to be scalable to millions of people? It's going to involve this amount of work. But the choice is ultimately theirs. It's a business choice. Finally in the list, confidence in the product. Confidence in the product is really a whole team decision. I very strongly recommend that you regularize this decision using a deployment pipeline to assert, is it ready for release? And to include everything that you need to know to have that confidence to release within the scope of the pipeline. The pipeline allows us to automate the vast majority of things that will help us to establish this confidence and so optimize the path to release. As I said before, quality is the whole team responsibility though. For a developer's perspective, a significant part of that responsibility sits firmly with us. This is not something that we can successfully abdicate to other people. So if you see testing as somebody else's responsibility, QA as the gatekeepers for quality, your manager's job to tell you how much quality you can afford to put into your code, I think that you should think again. Thank you for watching.